Hi everyone, I hope you are doing good. In this lecture itself, we will discuss about the flat belt designing procedure. This particular topic comes under the ME8651 Design of Transmission System in 6th semester Mechanical Engineering. So before starting the lecture, I would like to say, so each and every power transmitting elements having some certain designing procedure based on PSG design data of birth. So that is a thing we are going to discuss in this class itself. Yes, the first drive, notations of a flat belt drive. So before starting the designing procedure, we have to aware about the notations. Small n and small d, they are speed and diameter respectively for the driving pulley. And capital N and capital D, speed and diameter for the driven pulley. And T, thickness of a belt. C, center distance between the pulleys, both driving and driven pulley. I, velocity ratio or speed ratio. L, length of a pulley. So these are the different notations we are going to using in the designing procedure. Yes, the very beginning step number one, we have to find the standard pulley diameter by using the relation as a velocity ratio. I is equal to capital D by small d, or I is equal to small n by capital N. So after finding the I value, we have to select the suitable standard nominal diameter which is available in a PSG page number 7.54. So and this table will be available in the PSG page number 7.54. So after calculating the diameters, we have to select the suitable standard diameter by using this table. This table available in the PSG page number 7.54. And then step number two, design power. So we have a formula for designing the power. So design power is equal to rated power into load correction factor, the whole divided by arc of contact factor, where the load correction factor will be available in the PSG page number 7.53 and arc of contact factor will be available in the PSG page number 7.54. Usually the rated power always given in the question itself, so we never worry about that. So now we are going to discuss about the load correction factor. So when you look at the PSG page number 7.53, this table will be available. So we have to find the suitable load correction factor according to the load. So now we have four different types of load. One is the normal load, and second one steady load, and third one intermediate load, and the fourth one shock load. So we have a corresponding value like 1.0 for normal load, 1.2 for steady load, 1.3 for intermittent load, and 1.5 for shock load. So we have to select the suitable load correction factor according to the load condition which is available in the PSG page number 7.53. And similarly, we have to find the arc of contact factor. So this arc of contact factor will be available in the PSG page number 7.54. So we have a formula. Arc of contact is equal to 180 degrees minus capital D minus small d, the whole divided by C into 60 degree, where so capital D is the diameter of a large pulley, small d diameter of a smaller pulley, C is a center distance. So after calculating the arc of contact factor, we have to select the suitable correction factor. So when you look at the table, so the arc of contact having some angles, 90s, 120, 130 is up to 250. So we have to pick the corresponding load correction factor as per the arc of contact. So these values will be available in a PSG page number 7.54. And step 3, we have to find the select the type of belt. So the conditions will be available in a PSG page number 7.52. So we have two different types of belting condition. One is the Dunlop high speed and second one Dunlop 4949G. So as per the speed, so for example, generally the medium duty and high belt speed. So for the if the system considering the medium duty, which means medium load and high belt speed, obviously we have to select the Dunlop high speed. And similarly, if the system having the heavy duty, which means heavy load condition and medium belt speed, obviously we have to select the Dunlop 4949G. So these are the two different conditions of belting which is available in the PSG page number 7.52. And step number 4, we have to find the load rating capacity and number of plies. So we know the common formula for belt velocity V is equal to pi dn per 60 in terms of meter per second. It's a basic formula we all know. And after that we have to find the load rating. So the load rating formula will be available in the PSG page number 7.54, and select the number of plies according to the load rating capacity which is available in the page number 7.52. Yes, when you refer the page number 7.54, we have to find the load rating. So obviously the previous sets itself we have select the belt type, right? One is a high speed Dunlop and second one Dunlop 948 4. So for this suitable belting we have a two different values. So per mm per ply. So we have to select any one of this value according to the belting condition. And we have another formula, load rating is equal to load rating 10 meter per second into V by 10. So when you substituting the velocity value here, we can find the load rating. So that is the formulas will be available in the 7.54. And when you refer the 7.52 page number, PSG page number 7.52, so this table will be available in the PSG page number 7.52. So as per the number, we have to find the number of plies based on a belt speed. So in the step 4 itself, we found the belt speed, which is velocity V. So for example, so 10, 15, 20, 25, 30. So we have a 5 different belt speed. So the suitable belt speed, we have to find the number of plies, either 3 or 4 or 5 or 6 or 8. So that is your step 4. And step 5, we have to find the standard belt width. So the belt width formula is equal to design power divided by load rating into number of plies. So here, so we load rating a number of plies is calculated in the previous step itself. So we have to find the, after substituting all those values, we have to standardize the belt width. When you refer the PSG page number 7.52, this table will be available. So the corresponding number of plies, either 3 or 4 or 5 or 6 or 8, we have to standardize the belt width. These are the values will be available. So for example, so I'm getting the number of plies is 6. So belt speed is 90. So that is the condition we calculated. For example, we have to select the next higher value of 90. So what is the suitable next higher value of 90? For number of plies is 6, so the first value 100. So that is the standard belt width. So that is your step 5. And step 6, we have to find the pulley width. So when you refer the PSG page number 7.54, this table will be available. So standard belt width. So the first condition, up to and including 125. So what is the pulley width? 13 mm. And second one, up to 125 mm and including 250 mm. So that is second condition, the pulley width wider than 25 mm. And third condition, above 250 mm up to and including 375 mm. So the standard pulley wider than the 38 mm. And the last condition, above 375 mm and up to including 500 mm. So the standard pulley wider than 50 mm. So this table will be available in a PSG page number 7.54. And step 7, we have to find the length of belt. So we have a 3 different formulas for individual open drive, crossed drive, quarter turn drive. So these are the different belt drives. So based on the question itself, they are mentioned which is the driving condition, either it's a open drive or crossed drive or quarter turn drive. So we have to select the suitable formulas. So that is the L formulas will be available in the PSG page number 7.53. So we have to select the formula based on a belt driving mechanism. That is the step 7. And the last step we have to find. So after designing the all those parameters, we have to select the other pulley dimension. So we have a 3 different condition. One is the cast iron pulley, and second one is the mild steel pulley, the third one crowning effect. So the each and every pulley conditions will be available in the PSG page itself. So when you are referring the, say for example, if the designing consists in the cast iron pulley, so we have to refer the PSG page number 7.56. Similarly, the for mild steel pulley, we have to refer the page number 7.57. For crowning effect, we have to refer the PSG page number 7.55. Yes, so now I'm going to explain about the cast iron pulley. So, for example, if the system consisting the cast iron, the both driving and driven pulley having the cast iron pulley, so we have to calculate the number of arms, cross section of arms, thickness of arm, radius of a cross section of arm, minimum length of footwork. So all those formulas will be available in the PSG page number 7.56. So these all are the very simple formulas. So if I know all those answer from the previous step itself, so I'm just substitute all those values, I'm getting the answer. That is the for cast iron pulley. And similarly, mild steel pulley, we have to refer the PSG page number 7.57. So for mild steel pulley, we have to find the number of spoke, minimum length of boss and thickness of rim. So all the three basic parameters will be available in the PSG page number 7.57. And similarly, the last condition, Croning effect. So when you refer the PSG page number 7.55, this table will be available. So the based on a large pulley diameter, capital D, we have to select the Croning height, H value. So H value will be available in the PSG page number 7.55. So in this lecture itself, we was discussed about the designing procedures for a flat belt. So now I just want to inform that. So as per the flat belt, so we no need to memorize any formulas and any values. So all those formulas and all those standard values will be available in the PSC database. So we have to remember the designing sequence start from a step 1 and end with the step 8. So that is the only thing we have to remember. I hope you all understood. Thank you.